Good evening and very welcome. Tonight we're going to talk about a topic called raw water, now in Kodachrome, part 1. When I say Kodachrome, I refer to color. Color in lakes, rivers, in our water reservoirs. And we're going to have a look at why and what it can cost you with increasing colors in your water reservoirs. Why the increased color? What affects it? Are there any remedies? Well, first let's look at what color is. Color is basically organic material or humic substances that is created when organic material is decomposed by thousands of different types of bacteria. Now, what will affect the amount of color is, of course, the land use, where the rain will wash away the organic material. Also, the temperatures. Higher temperatures means more work from the bacteria, creating more organic material. Or the rate of the decomposing will increase with higher temperatures because of happy bacteria. Also, precipitation, increased precipitation, more intense precipitation will move more organic material from the land, and this is also a problem, of course. Temperatures and precipitation is, of course, also connected to the discussion about climate change now. Furthermore, there is a talk about sulfur deposition, basically that in the old days, when you have power plants spewing out sulfur dioxide, you had acid rain, which we don't have as much or very little of today. The acid rain was quote-unquote beneficial because it lowered the pH in the soil, so the humic substances was kept in the soil and was prevented from moving when the water came down. But the sulfur deposition has decreased, so the release of organic substances are now thought to be higher because of this decrease in sulfur deposition. So, what measures can we take? Well, actually there is only one, or should I say many. Protect our watersheds. And I've talked about this in one of the videos I made about New York and how they're protecting their water reservoirs. Please have a look at that video. It's actually some very good measurements that New York did to protect the watersheds. But basically, protect the watersheds as good as you can to minimize the release of organic material and the increased color in our lakes and reservoirs, so raw water supply. Color is an indicator of organic material, as I said before. And the unit for color measurement is milligram PT per liter. And if you look at organic material, there is measurement of COD, chemical oxygen demand, and TOC, total organic carbon, in the unit milligrams per liter. Drinking water. Before distribution, you should have a color less than 15. So you see the glass here, a very clean, clear water. Now, in a previous video, I talked about the pilot trial I did in the Muscan Lake. And that lake that we tried to use nanofiltration on had a color of above 50, peaking at 60. And here you see this is about 50-60 in color. And then you have even higher colors. In Lyckebyen or Lyckeby Creek, you have color that ranges from 150 to 200 milligrams PT per liter up to maybe 300. And here you can see very high colors. Now, compare this to the Baltic Sea, which is one of the major recipients. There the color is, well, less than 5 up to maybe 10. And in this case, we took some grab samples during 2017, but I think that's a pretty good reference value when you talk about color in the Baltic Sea, which is it's a brackish water also, of course. There are other recipients, the Baltic Sea, Kattegat, Skagerrak, for Swedish watersheds. And in these, there has been indications of an increase in organic content also. That's about the measurement and some values, parameters for color. So if you want to know how to treat the water, what cost there can be, then you need to look at the next part 2 in this series. So watch the video, part 2, and you'll find out all about the treatment methods and the costs. So before you watch part 2, let's have a look at some beautiful pictures with my 135mm lens. With that, I'll say thank you and remember, water really, really rocks. Take good care and bye-bye.